Array W is given. First, we are printing the complete array. The colon means the complete array. The colon -2 is removing the last is length -2. So this last two elements are neglected, and we are printing the remaining array. The colon 5 is the colon is complete, considers the complete array, and then we are considering the fifth element. So we consider the first element. The fifth element after that is 8, and again the next fifth element is 3. So which is printed here. In the third, we are considering the array from 2. It includes 2, which is the lower bound, and excludes -2, which is the upper bound. So our new array is from this 2 to 3, and in that it will consider the sixth element. So it considers the first element, and then the next sixth element is 6. 1, 2, 3, 4, 5, 6. So here we are printing 1 and 6. In this function, we are printing the given nested list in the form of a two-dimensional array. With this function, we are passing the list. NP-array is the library that we are using to convert the list into an array, which has been printed over here. In the second function, we are calculating the average of each month number of sun hours. So to calculate each month, we are adding the columns of the two-dimensional array. So to add the columns of the two-dimensional array, we are considering axis 0, and then we are dividing it by the number of elements we are adding. So this function add gives us the average of the number of sun hours for each month. So to print that, we have created new array, which is all the names of the month. And using this function, we are printing the name of the month and the mean value of average value of temperature or the sun hours for each month. In the next function, we are calculating the best weather month. So from the previous function, we have all these values. So we are calculating the best, the maximum of it, which is June, we can see. So we are taking the maximum value is saved over here. Here we are taking the index of the maximum value, which is 1, 2, 3, 4, 5, 6. So this is 6th value, and with that 6th value, we are calculating the month, which is June, and that month will be saved, and we are printing the answer. June has the best weather with 196.1 sun hours on average. In the third one, we are calculating the average temperature for January and December for a decade. So to calculate that, here we are considering a formula for the decade, which is starting from 1930 to 2010, and decade is 10 years, so we are considering 10. So S is where we are going to save the sum. Here the decade is 1930, where it starts. This is to calculate which row we are considering. Each row represents the year, and each column represents the column in that it represents the month. So we are considering the month. Here, using this function, we are considering the December month for those 10 years, and this is the January month for those 10 years. We are adding those, and we are dividing because 10 years, 2 is because we are considering 2 months, and we are calculating for each day. So on an average, we are considering the number of days is 30, and we are dividing this value by this 10 into 2 into 30, and it's saved in decade. Using this function, we are printing our results. So this is our result for each decade. In the next function, we are printing a graph for the velocity formula. The values are given. These are the libraries to plot the graph. So V is the velocity, G is the gravitational force, time is given in the function in the problem statement, the time line span. This function, this is the graph we are plotting. We are plotting time y. P is the color of the graph that we are plotting, and label is what we are printing here. The position of the label is given here, upper right corner. The title of the graph is here. The X label is time, the Y label is height in meters, and here is our plot graph. The next function is similar, but in this function we are taking the velocity. Here we have defined the velocity. Here we are taking the velocity value from the user and we are plotting the graph. So when we execute this, let's say enter the 4, 5, and 6. Here is our graph. The values of each velocity is been printed over here. This is the plot for velocity 4, 5, and 6. We are passing this value here and printing the labels, and the label is printed in the right corner, and the function is pretty similar to the previous function except this part where we are getting the values from the user. In the next function, the addition thing is we are adding the values to the maximum limit of x and y axis. So to plot this graph, we are giving value 20, 30, 40, and here is our graph. The only difference is we have defined the value of x and y axis. In the next graph, we are plotting the graph from Celsius to Fahrenheit temperature conversion. The first formula we are using is a simple formula. The second one is the exact formula. We are calling these functions over here and calculating the value of Celsius temperature using the formula. And here we are plotting those formulas. The y is the Celsius, x is the Fahrenheit temperature. And again, the label is printed over here in the upper right corner, and which we can move because it's blocking. We can do it in the left corner. So this looks better. And this is our graph. In the last function, we are printing the sine wave. This is the function of the sine wave, which we are calculating and saved in y1. X is line is between -4 to 4. This is y when t is equal to 0. We are again printing the label in the right corner, and the title is given over here. We execute the function.